Hello everyone, in this video we'll try to solve past exam problems on derivatives and integral. Don't forget to like and comment. The first question says we have given a function f of x and then we need to find the derivative. So our function f of x is ln of x times square root of x. Simply we are asked to derivate, so we have to derivate ln first and then the inner derivative. We have to apply here chain rule. So the derivative will be the ln derivative, 1 over everything, that is x square root of x, times the inner derivative x square root of x will be derivated. But when I derivate this one again, I have to apply product rule. That means the first function derivative times the second one plus x times the second derivative. This is chain rule, product rule. And x derivative obviously 1, so 1 times root x will be root x, plus radical x derivative is 1 over 2 root x, so x over 2 radical x I will have. Then crisscross, when I multiply these two, it will be 2x, radical x times radical x, plus again 1 times x will be x, the bottom part will be 2 radical x. So the final will be 3x over 2 radical x. It means the product part only. So when I connect now, the derivative will be, the derivative of the x will be 1 over x radical x times the product part, we got it already, 3x over 2 radical x. So what to do here? We can cancel this x and this x. Okay, we can cancel out. Then what remain at the top? 3 times 1, 3, and the bottom radical x times radical x will be x, so 2x will remain, so the answer is going to be D. The next question, the volume V of a melting ice cube after t seconds is given in centimeter cube, and how fast it is, how fast the volume is changing in centimeter cube per second when the time is 40 seconds, it says. So first let's write the volume. The volume is 2000 minus 40 plus 0.2t square. So how fast is the volume changing? Means the rate of change of volume with respect to time means dv by dt, and when the time is 40 seconds, it says. So first let's derivate it. When we derivate this volume, constant derivative is 0, so I can ignore. Negative 40 derivative will be negative 4, and this one, when I derivate, the 2 will come and multiply the coefficient number, it will be plus 0.4t. Now since the derivative dv by dt, it's asked at the time 40 seconds, so I'm going to substitute now 40 in place of time. So what I will have, negative 4 plus 0.4 times 40, that's going to be negative 4 plus just 16, because the point and the 0 cancel each other, so the answer is going to be 12. Unfortunately we cannot get the answer here, but it's okay, this is the answer. The volume dv by dt will be centimeter cube per second. The next question, at what values of x the function you have a local maximum? So when we are asked the local maximum and minimum, what to do? First we'll derivate and factorize sign chart, and then we have to observe the positive and the negative intervals. Positive intervals are increasing, so let's go on. What is our function here? It says 1/3 x cube minus half x square minus 2x plus 1. So the process, the first step, derivate it. When you derivate it, these 3 will come and multiply the coefficient number, so they will cancel each other, so x square remain, minus again the 2, the same thing, it will multiply the coefficient number, so just x remain, minus 2. When we try to factorize this one, we have to think of two number, product negative 2 and sum negative 1, so that that's going to be negative 2 and 1, so x minus 2 and x plus 1. That's going to be the factorized form. I hope you know how to factorize. So when I apply now sign chart method, the zeros are negative 1 and 0, so I will plot negative 1 and 2 here and here. And then what are the factors? X minus 2 and x plus 1 I have. X minus 2 will be 0 at here, and then less than negative, greater than positive, and x plus 1 will be 0 at negative 1, positive, positive. And finally, when I multiply here positive, negative, and positive, I will have. So we are asked local maximum. Local maximum point will be found when the time change from positive to negative. From positive to negative will be maximum, and the minimum will be from negative to positive. So where is the change from positive to negative? It is at the point here, from positive to negative. It is changed at last. So the point must be at x is equal to -1. It has local maximum. If we were asked the local minimum, the sign change from negative to positive is found at 2. That was supposed to be the answer, but this time the answer is going to be -1. The next question, what is the equation of the tangent line for the function? We have a function f of x which is 3x squared plus 4x minus 5. The point is given to us at 1, 2. We can take this point as x1, y1, or we can say this point as a comma f of a. So when you remember the formula equation of line, y minus f of a is equal to f derivative at a in bracket x minus a. What does this this expression means? You know, it's the slope. So our objective is to get that, because the remaining we do have everything. We can substitute. Y minus f of a is, you know, to the second order, which is equal to f derivative at a, then x minus 1. You know, f of a and ar we do have here. So we are going to solve f derivative at a, or the slope, first. Let's get it. To get f derivative at a, first let's derive the function. What will be the derivative of this quadratic function? It's going to be 3x squared derivative is 6x plus 4x derivative will be 4. So when I insert now 1, because f derivative at a means our a here this time it's 1. When I insert 1, it will be 6 plus 4, that is 10. So this equation of line is going to be now f minus 2, y minus 2 is equal to 10 in bracket x minus 1. So we have to reshuffle and finish it. Y is equal to 10x minus 10 plus 2. So y is equal to 10x minus 8. So which equation is containing this expression? 10x minus y minus 8. Yeah, that's going to be a. We can reshuffle and bring the y there. It will be 10x minus y minus 8, which is equal to 0. So the answer is going to be a. Next question, what is the absolute maximum value of the function? We have a function here that is 2x squared minus x to the power of 4 minus 4. The interval is given to us. This time we are asked absolute maximum, or it can be absolute minimum, since we have interval. What to do? Derive and get the zeros of the derivative, including the boundary numbers. That's going to be critical numbers. Then evaluate at each critical numbers. So the larger will be the maximum and the smaller will be the minimum. That's the step. So anyways, we have to start by derivating. When I derive this function, you know, 2x squared derivative will be 4x, and this derivative will be 4x cubed, and then take out common. That's going to be 4x common. Then 1 minus x squared remain. Still we can factorize it. 4x in bracket 1 minus x squared can be factorized as 1 minus x and 1 plus x. Then this time let's find the zeros. There are 3 factors, as you see. The first factor will be 0 at 0, the second one at 1, and the third one at -1. Then those factors, check whether they are found or not in the interval. Yes, each of them found except the -1, so we can forget -1. And then critical numbers. The critical numbers are, what are they? Including the boundary numbers 0, 1, and 2. That means I will evaluate at 0, at 1, and at 2. The original function will be evaluated. So when I insert 0 now at the original function here, 0, 0, so -4 remain. And when I insert 1 again in the original function, this will be 2, and 2 minus 1 it will be 1, 1 minus 4 will be -3. And when I enter 2, it's going to be this one 8, and 16, -8, that's going to be -12. Imagine now from these 3 numbers we will compare which one is the larger number. The larger number is this one. So this is absolute maximum value, and the minimum will be the lower one. That's going to be the absolute minimum value. So we are asked the absolute maximum value, so the answer necessarily will be A. Okay, next one, we need to find using the figure which of the following is true about f of x, it says. But the graph, what's given here, it's the graph of the derivative. It says here y is equal to f derivative of x. So remember, when you see the choice, it's talking about increasing, decreasing, local maximum, and extreme values, those things. So remember the rule: the derivative of the function is greater than 0 intervals are increasing, we don't have to forget, and the derivative of the function less than 0 intervals are decreasing, and from positive to negative sign change will be maximum, and from negative to positive, from negative to positive, it's going to be minimum. And then those maximum and minimum value found, the maximum and the minimum value, the point that maximum and minimum found will be extreme values. So where is the positive intervals? The positive intervals are from, when you try to see the graph now, from A until D, like from A to B I can say, or from B to C, or from C to D. Those are increasing because the graph is completely above the x-axis, means it's positive. The graph below the x-axis are negative interval of the derivative, that's going to be decreasing. So let us see the choice now. The first choice A says f is increasing between C and D. Where is C? Here it is. And what about D? Here it is. Yeah, between C and D, the graph, as you see, it's completely above the x-axis. That means the function, the derivative will be positive, so it will be increasing. Yes, that's correct. Since we are asked which one is true, yes, we did it. But if you see B, for example, it says it is decreasing between B and C. Between B and C, as you see, the graph is, again, it's above the x-axis. It should be increasing. It's positive. Positive means it's increasing, so that it doesn't work. C, f has local maximum at D. First of all, maximum at A. Try to see here at A. At A there is sign change. From what to what? The graph was positive, negative below the x-axis. It's changed to the positive one at A. So this is going to be minimum. A will be minimum. And what about D? It is converted or changed from positive to negative. The graph from above, it goes to below the x-axis. That means from positive to negative. That's going to be maximum. But at C there is no change of sign, so we cannot say take C as an extreme value, so D doesn't work. And even C says f has minimum at D, says, but at D it should be maximum, because at a point D it changed the sign from positive to negative, so the answer should be A. The next one: which of the following interval is the graph of f of x concave upward? To study the concave up and down interval, we have to derive the function twice, and then positive intervals will be concave up and negative interval will be concave down. So what's our original function this time? That is ln of x squared plus 1. So let's derive it first time. The first derivative will be, ln derivative will be 1 over x squared plus 1 times the inner derivative will be 2x. So I can write it as 2x over x squared plus 1. This is the first derivative. Let's go in and do it for the second derivative. If second derivative will be, we have to apply this time quotient rule. That is the upper derivative times the lower as it is, minus the upper as it is times the lower derivative, the whole over the lower square. That is the rule of quotient rule says. So as I told you before, since we are going to observe the sign of the second derivative, positive or negative sign, so the denominator part here, what we say, this square thing, it doesn't affect us. We can ignore it. The reason, square of whatever the number here, it will be always positive, so it doesn't have any effect. So the upper part, what remain, 2x derivative, it's 2, so the 2 will multiply each of them. So it will be 2x squared plus 2 minus, I have to go on minus. Again, this bracket derivative will be only 2x, and 2x times 2x will be 4x squared. So finally what remain, 2x squared and minus 4x squared will be negative 2x squared. So 2 minus 2x squared left, which is 2 in bracket 1 minus x squared. So we can factorize still 2 in bracket 1 minus x and 1 plus x remain. Okay, so what are the zeros of these factors? First one 1, the second one negative 1. Okay, let's construct sign chart. At negative 1 and 1 there will be 0, and the two factors are 1 minus x and 1 plus x. The upper part will be 0 here, and less than positive, take care, and greater than negative, because the coefficient of x is negative. and the second part will be 0 at -1, then negative, positive, positive, and then we can see now the product negative, positive, and negative. So what will be the positive interval? It is between -1 and 1, so that it is concave up, because this is second derivative. We are studying the second derivative behavior. So concave up in the interval from -1 to 1. So the answer necessarily will be D. Okay, let's continue to the next one. The volume of the solid, which is generated when the region bounded by y equal to square root of x plus 1 and x-axis from 0 to 2 is rotated about the x-axis, it says. Okay, that means we have function and the evaluation also we do have. So volume will be generally formula pi times the integral from a to b, the given function, since it's one function, square it dx, so which is equal to, our a and b are 0 to 2, it says, and our function is square root of x plus 1. We have to square it dx, and there must be pi here. Therefore this is going to be pi, the integral 0 to 2. When we square, x plus 1 remain, the radical will be removed, so pi keep outside again. The integral of x will be half x square, the evaluation from 0 to 2, plus the integral of 1 will be just x, again from 0 to 2. Okay, this is the integral from 0 to 2. Okay, let's complete it. So the volume will be pi still outside. This one, when you evaluate 4 minus 0 units 4 over 2 will be just 2, plus, and here also 2 will be remain. So when you add it, the answer will be 4 pi. So that's going to be A. The next one, it says, in which of the following interval the given function increase? Again, like that of the previous questions, we have to derive first. What is the derivative of the given function? It will be 4x cubed plus 4, because our function is here. So when I derive 4x, x to the power of 4 will be 4x cubed, and 4x will be just 4. So what's common? 4. What remain? X cubed plus 1. So we can factorize this as 4 times x plus 1 and x squared plus, minus x, okay, minus x plus 1 is equal to 0. So the only 0 point will be x plus 1. But if you don't want to do, if you don't want to proceed in this way, the process, first derive it. Obviously we derive it and then get the zeros. What makes the 0? 4x cubed is equal to -4. When I shift this 4 to the other side, divide by 4 both sides, so x cubed is equal to -1. Then put in the cube root both sides. Okay, cube root of -1. So x value is equal to -1. So it has only one 0, the derivative. What is the derivative? It is 4x cubed plus 4. So this will be 0 at -1. So less than negative, greater than positive. Therefore, since we are asked increasing interval, here increasing, positive interval, and here it is decreasing. So f of x will be increasing on the interval from -1 to infinity. So the answer is going to be C. Next one, at which values of x does the function has local maximum? Again, we have a function f of x which is equal to 1/4 x to the power of 4 minus 2x squared. This is a power of 4. Okay, local maximum, that means I have to derive it again. The derivative will be, the 4 will come and multiply. So simply x cubed remain minus this derivative will be 4x. So what's common? Just x. So what remain? X squared minus 4 remain. I can factorize this. So it will be x minus 2 and x plus 2. So the zeros are like 0, here 2, and here -2. Okay, let's construct sign chart. First one -1, and then 0, and then 2. We have to write in order. And what are the three factors? Just x, x minus 2, and x plus 2. So x will be 0 at 0, less than negative, and greater than positive. The same way this one here at 2. Okay, and this one will be here. Okay, finally 3 negatives will be negative and 2 negative will be positive. We are trying to see, and here negative, positive. So we are asked maximum. We have to see the sign change from positive to negative, which is here at 0. So at x is equal to 0, it has maximum. The local maximum value will be found there. The next question, what is antiderivative of the given function? That means the integral. So we'll integrate 2 over 4x squared plus 4x plus 1 dx. That means first I have to factorize the denominator part. When we factorize, it's going to be the integral 2 over 2x squared, 4x squared. Yeah, let's finish the factorization part. This will be factorized as 2x plus 1 times 2x plus 1, which is 2x plus 1 square. Yeah, you can get it in that way. The factorized form will be 2x plus 1 square dx. So to integrate this one, we can use substitution. You can take the denominator part as u, which is 2x plus 1. When I derive both sides, du will be 2 dx. So divide by 2, so half du is equal to just no need, because here there is 2 at the top. So the integral will be, now when we write it, it will be just du over u square, which is the integral u to the power of negative 2 du. When I integrate it, plus 1 I will make, so negative 1 over u to the power of, u to the power of negative 1 over negative 1. So I will write it properly, this one. It's going to be negative 1 over u. The negative in the denominator part, I can bring it up, and the u, since the exponent negative, I just brought it down, so it will be negative 1 over what is u to x plus 1. So the answer is going to be C. Okay, the last question for this video, last one. What is the value of the integral from 0 to pi over 2 to x cos x dx? First of all, let's take out these two constant, and then let's apply here. Since two functions multiply, we can use integration by part. Let's take u as x and dv as cos x. When you integrate u, du will be 1, and when you integrate the v, cos integral will be sin x. So what does by part rule says? First go on here diagonal uv, first multiply uv here, and then v du. So that's going to be, uv means x sin x minus the integral sin x dx. So it will be x sin x. Sin x integral is positive cos x, so plus cos x. The evaluation is from 0 to pi over 2 and from 0 to pi over 2 for both. Okay, let me write it here properly. Let's mix it up. This is x from 0 to pi over 2, and here there is plus. Okay, let's evaluate it now. The first part, when I insert pi over 2, it will be just pi over 2 remain, minus when I insert 0 will be sin 0 0, so everything will be 0. The first part only, this one. The second part, when I insert cosine pi over 2 will be, it's 0, and when I insert 0 it's 1. So that means pi over 2 minus 1 will remain, so the answer is going to be D. So these are some of selected problems for the preparation. Okay, I think one question. Yeah, I do have one question. Here it is. Let's do it. It says again antiderivative, that means the integral tan x dx. So what to do? Tan x can be written as sin x over cos x dx, and then again we can apply here substitution. Let us take the denominator part as u. When I derive both sides, du will be negative sin x dx, but there is no negative, so I can multiply both sides by negative, so negative du will be sin x dx. As you see now, the topper part sin x dx will be replaced by negative du. So what can I have now? Negative du over u remain, the integral. That means negative of ln just u. That means negative of ln, what's u? Cos x. but unfortunately we cannot find this one in the choice, so I can bring this negative as an exponent of cos, so it will be ln of cosine x the power of -1. That means ln of 1 over cos x, but 1 over cos x means sec x, so finally our answer will be ln of sec x, because 1 over cos x means sec x, so the answer is going to be which is, I mean, yeah, D. So these are some of selected problems for this video. Thank you for staying with me.